In this module, I'll cover mesh analysis, which is a circuit analysis technique that relies on what we call mesh currents. So in this video, I'll cover an overview of how to utilize this analysis, the result of the analysis, and in a separate video, I'll walk you through the procedure of performing the actual analysis and getting the mesh current. So I'll start off with this example in here. So in this example, I'm giving you a circuit, and that circuit has one source that is 12 volt, and you can assume that all the resistors in here are 1 ohm, just for the sake of simplicity. So when you perform mesh analysis, what happens is you'll end up with what we call mesh currents. And mesh currents are usually referred to like this. So you'll see or notated this way. So this is a current. For example, we can say that this is I1, and here's another current, and that's basically I2. And here's a current in here, and this is what we call an I3, and there's a current in here, and that's I4. So these are what we usually call as mesh currents, and mesh currents are not the same, or not necessarily the same, as the currents we're used to, which we typically refer to as branch currents. So let me explain. So what happens, like, we have different resistors in here, and these resistors will have different currents in them. So for example, R1 will have a current, R2 will have a current, and R3 will have a current. So what I'm saying is there's a distinction now between the currents. So we have branch currents. These are the actual currents that are flowing through the branches. And we have what we call a mesh current. So the mesh current is a current that flows, well, it's a fictitious current that actually flows through what we call a mesh. A mesh is just simply a loop that doesn't contain any other loop. So this is a mesh in here, and this is a mesh in here, and this is a mesh in here, and this here is also a mesh. So that's why we have 4 different mesh currents. Okay, so how does a mesh current relate to a branch current? So let me do this with an example. For example, I can tell you that I1, after you calculate and do mesh analysis, you'll end up that I1, the mesh current is actually 4.8 amps, and you'll end up that I2 is 2.4 amps, and you'll end up that I3 is 1.2 amps, and also I4 is 1.2 amps. All right, so what we have now is we have the mesh currents. So again, these mesh currents are fictitious, but they're very useful. Fictitious meaning they're not necessarily measurable. So if you go to the lab and you're trying to actually measure them using an ammeter, you will not get these, not always. Some of the currents you might, some you don't. But in general, they're fictitious current. The branch currents, on the other side, or on the other hand, you can actually measure them in the lab. You can go and put an ammeter and you can measure them. So how do mesh currents relate to branch currents? Well, here's how they do that. For example, let me just call this one here is IR1. So as it turns out that in here, what I have is I have this mesh current in here that is, I'm assuming that is actually flowing this way, which is I1. It is the same as IR1 because none of the other mesh currents in here are flowing through IR1. So I can simply say, well, IR1 is exactly the same as I1, which is 4.8 amps. Okay. What about, let's see, the current going through here? Of course, it's, well, if you know that IR1 is 4.8 amps, you should know that the current flowing through this voltage source is also 4.8 amps because they're in series. So let's take a look at another part in here, for example, R6 in here, okay? So let's figure out, maybe I'll assume that the IR6 is flowing that way. So we'll do that. This is IR6, okay? So what's with the IR6? Okay, so we can say the IR6, well, if you take a look, you'll see the I1 actually flows through it, and I2 flows through this R6. So as it turns out that this R6 have 2 mesh currents flowing through it, which is I1 and I2. And the rule usually is, if you want IR6, which is a branch current, it's the current that is actually flowing through the resistor, you can utilize these 2 mesh currents to actually compute them. So I1 is in the same direction as IR6, so I will say, well, it's I1, and well, I2 happen to be moving in the opposite direction of IR6, so I'll say minus I2. And I substitute the values, I'll get 4.8 minus 2.4, and you will get that number, okay? Which simply is also 2.4 amps, okay? So now I know that this branch current, which is the current flowing through the R6, is simply 2.4 amps. And you can continue. For example, you can figure out what the IR3 in here. For example, this is IR3. Okay, so how do I do the IR3? Well, IR3 has I3 and I4 flowing through them. These are the mesh currents that flow them. Since I3 is in the same direction and I4 is in the opposite direction, I can just simply say the IR3 is simply I3 minus I4, and I substitute the values. These are 1.2 minus 1.2, and it just happened to be 0 volts or 0 amps. So there's technically no current flowing through this R3. So this is how useful mesh current is. So in mesh analysis, you'll end up with these currents I1, I2, I3, and I4, and you'll be able to figure out any branch current you want in the circuit. And figuring out any branch current will pretty much give you any voltage you want. If we're talking about resistors, we can compute powers if we have a voltage source, and so on. So mesh analysis will allow us, like other analysis technique, to figure out all the voltages and the currents in the circuit. However, I just want to re-emphasize that branch currents and mesh currents are separate. So for example, if you go to the lab, you will be able to measure what IR1 is by just putting an ammeter in series with the R1, and you'll figure it out. And as it turns out, the I1, because it's the only one flowing through here, you can measure I1. But let's take a look at I2 in here. So I2, there's no way you will be able to measure I2 in the lab. Okay, because I2, because if you think about I2 flows through R6, but we know that R6 is actually the effect of I2 and I1. Okay, if I take a look at this here, let's call it IR2, for example, we will know that this is actually the effect of I2 and also the I4. Okay, so that whatever branch current in here that we will measure will contain I2 and I4. All right, how about the I3 in here, or the R8, sorry. So the R8 is the effect of I3 and I2. Okay, so the current that is flowing through it is the effect of these two. So as it turns out, that this I2 affects R6, R2, and R8, but it also, all of these three resistors are also affected by I1, I3, and I4. So I won't be able to basically relate a branch current directly to I2. I2 just contribute to these branch currents. So this is why we say that they're fictitious currents. However, they're very useful. And so let's try to figure out how we can compute these mesh currents.